Welcome back to the channel where medical and science topics are made easy. In this video, we're going to simplify the different body cavities and membranes, and by the end of the video, you'll know this entire flowchart, as well as everything in the table, so make sure to watch until the end. We're going to come back to the flowchart throughout the video, and then summarize everything at the end with the table. Remember to turn on those captions down below and read along. This will help you remember everything. So let's get right into it. First, we have to ask ourselves, what is a body cavity? A body cavity is a space or compartment in the body that houses organs or structures. In other words, they're the spaces left over when internal organs are removed. We're going to make body cavities simple to understand by making a flowchart. First, there are two main cavities in the body. They include the dorsal cavity and the ventral cavity. We've talked about the terms dorsal and ventral in past videos. You might recognize this image from our previous video on anatomical directional terms. It'll be linked down below in the description. In that video, we learned that anterior means front or toward the front of the body, and that posterior means back or toward the back of the body. We also learned that another name for anterior is ventral, and another name for posterior is dorsal. You can think of a ventriloquist for ventral, which literally translates to stomach talker. And if you point to your stomach, then you're pointing to the front of your body, and this can help you remember ventral means front. For dorsal, you can think of a dorsal fin on the back of a fish to help you remember dorsal means back. You might also recognize this image and table from our medical prefix video. That link will be in the description as well. We learned that the prefix ventri means stomach, abdomen, toward the front, or the anterior aspect of the body. We also learned the prefix dorso means back or posterior. Now that we know dorsal means back or posterior, and ventral means front or anterior, we can apply those terms to the dorsal cavity and ventral cavity. Starting with the dorsal cavity, we know dorsal means back or posterior, so the dorsal cavity is the cavity located in the back of the body. The dorsal cavity is the green cavity on the image. Let's highlight the dorsal cavity in red to make it pop out. You can see how the dorsal cavity is situated behind or posterior to the ventral cavity. So that means the ventral cavity is the cavity located in the front of the body, which makes sense because ventral means front or anterior. The ventral cavity is the tan beige cavity on the image. Let's also highlight this cavity in red, and you can see how the ventral cavity is situated in front of or anterior to the dorsal cavity. Now that we have a good understanding of the dorsal and ventral cavities, each cavity can be broken down even more. Let's start with the dorsal cavity. The dorsal cavity can be subdivided into two main parts. We have the cranial cavity and the spinal cavity. Let's look at the cranial cavity first. We're going to go through the high-yield features of each cavity. The cranial cavity is the superior portion of the dorsal cavity, as we can see highlighted in red and labeled by the star. The cranial cavity is enclosed by the cranium or skull, and it houses the brain. The cranial cavity also contains fluid called cerebrospinal fluid that helps protect and cushion the brain. Each cavity is also lined with thin sheets of tissue called membranes. The cranial cavity is lined by a three-layer membrane called the meninges, which protect and cover the brain. The three meningeal layers are the dura mater, arachnoid, and pia mater. Let's take a closer look at the cranial cavity and all of its features. We're looking at a side view of the brain and skull called a sagittal view. As we mentioned before, the cranial cavity is enclosed by the cranium or skull, which we have highlighted in green. You can see how the skull has formed an empty space or cavity. This space created by the skull is called the cranial cavity, which is shown in yellow. We know the cranial cavity contains the brain, which we'll color in red. Now, as we said before, the cranial cavity also contains fluid called the cerebrospinal fluid or CSF. The CSF helps protect and cushion the brain along with other functions, and it's located in the subarachnoid space between the meningeal layers. Remember we said the cranial cavity is lined by a three-layer membrane called the meninges. The pia mater is the innermost layer and closely adheres to the brain. The pia mater on the image is the inner black line between the brain and CSF. The dura mater is the outermost layer, and the arachnoid is the middle layer. They're represented by the outer black line on the image between the skull and CSF. Remember, the CSF is located in the subarachnoid space between the arachnoid and pia mater. Let's look at the diagram in the bottom left showing the layers to help refresh your memory. First, we have the skull on the outside, which is what the cranial cavity is enclosed by. Below the skull is 3 layers of membrane called the meninges. The 3 meningeal layers are represented by the stars. The outermost layer of the meninges is the dura mater, which is located beneath the skull. Below the dura mater, we have the arachnoid, which is the middle meningeal layer. There is a space below the arachnoid called the subarachnoid space, and this is where the CSF is located. The innermost meningeal layer is the pia mater, which adheres closely to the brain. So hopefully this helps to visualize the cranial cavity better. If we go back to the flowchart, we now have a good understanding of the cranial cavity and how it contains the brain. Now let's look at the features of the spinal cavity. The spinal cavity is also known as the vertebral cavity, and it's the inferior portion of the dorsal cavity. The spinal cavity is continuous with the cranial cavity, as we can see highlighted in red and labeled by the stars. The spinal cavity is enclosed by the vertebral column or spine, and it houses the spinal cord. The spinal cavity also contains cerebrospinal fluid that helps protect the spinal cord. Remember, the cranial cavity and spinal cavity are continuous with one another, so it makes sense they both contain CSF. Likewise, the meninges line the spinal cavity, just like the cranial cavity. Let's take a closer look at the spinal cavity and its features. We're looking at the same side view of the brain and spinal cord. As we mentioned before, the spinal cavity is enclosed by the vertebral column, which we have highlighted in green. You can see how the vertebral column has formed an empty space or cavity. This space created by the vertebral column is called the spinal cavity, which is shown in yellow. You can see how the spinal cavity is continuous with the cranial cavity above it. We know the spinal cavity contains the spinal cord, which we'll color in red. Now, as we said before, the spinal cavity contains CSF just like the cranial cavity because the two cavities are continuous with one another. The CSF is again located in the subarachnoid space between the meningeal layers. Remember, we said the spinal cavity is lined by the meninges as well. The spinal meninges are similar to what we saw with the brain. We can use the circular cross-section as a reference. It's like we're looking down at the spinal cord. We have the spinal cord in the center, which is housed in the spinal cavity, and the spinal cavity is enclosed by the vertebral column, represented in green. The 3 meningeal layers line the spinal cavity and are shown by the stars. The pia mater is again the innermost layer and closely adheres to the spinal cord. The dura mater is the outermost layer, and the arachnoid is the middle layer. Remember, the CSF is located in the subarachnoid space between the arachnoid and pia mater. If we fill in our cranial cavity again, you can really appreciate how the two cavities are continuous with one another. The cavities are enclosed by the skull and vertebral column in green, which house the brain and spinal cord in red, and the cerebrospinal fluid in yellow is in the subarachnoid space around the brain and spinal cord. So hopefully this helps to visualize the spinal cavity better. Let's go back to our flowchart. We now know the cranial cavity and spinal cavity make up the dorsal cavity. The cranial cavity contains the brain, and the spinal cavity contains the spinal cord. In other words, the dorsal cavity houses the central nervous system because we know the central nervous system is made up of the brain and spinal cord. Now let's move on to the ventral cavity. The ventral cavity can also be subdivided into 2 main parts. We have the thoracic cavity and the abdominopelvic cavity, which are separated by the diaphragm. Let's look at the thoracic cavity first. The thoracic cavity is the cavity in the chest. It's the superior portion of the ventral cavity, and it's above the diaphragm, as we can see highlighted in red. The thoracic cavity is enclosed by the rib cage, vertebral column, and sternum. The main contents of the thoracic cavity include the heart, lungs, trachea, esophagus, and the great vessels. The thoracic cavity is also lined by membranes, and in order to better understand these membranes, let's first go back to our flowchart. The thoracic cavity can be subdivided even further into the pleural cavities and the mediastinum. Let's look at each of these, starting with the pleural cavities. The thoracic cavity has 2 pleural cavities, a right and a left. The pleural cavities surround the lungs. The right pleural cavity surrounds the right lung, and the left pleural cavity surrounds the left lung. You can see the right lung highlighted in red, with the right pleural cavity surrounding it shown in yellow. The left lung is uncolored as a reference. Each pleural cavity has a small amount of fluid called pleural fluid. This helps lubricate the lungs as well as the membrane lining the cavity when breathing in and out. The pleural fluid is located in the pleural cavity, also known as the pleural space, which is the potential space in yellow between the lungs and chest wall. Each pleural cavity is lined by a serous membrane called the pleura. The pleura folds on itself to create a double-layered membrane shown in green and purple. The inner green membrane that lines the lung is called the visceral pleura, and the outer purple membrane that lines the chest wall or thoracic cavity is called the parietal pleura. The potential space between the visceral and parietal pleura is the pleural cavity or space shown in yellow. Here is another picture of the lung to show the inner visceral pleura, which lines the lung, and the outer parietal pleura, which lines the chest wall or thoracic cavity. You can also see the pleural cavity or space between the visceral pleura of the lung and the parietal pleura of the chest wall. The pleural cavity contains a small amount of pleural fluid. So now we know the right and left pleural cavities and lungs make up part of the thoracic cavity, as we can see highlighted in blue. But now we have this middle area of the thoracic cavity highlighted in yellow that we need to talk about. This is called the mediastinum, and it makes up the middle portion of the thoracic cavity. You can remember the M in middle and mediastinum to help you remember this. The main contents of the mediastinum include the heart, trachea, esophagus, great vessels, and thymus gland. We can see how the outer parietal pleura we discussed before lines the mediastinum. There is one more cavity to talk about within the mediastinum, and that's the pericardial cavity. The pericardial cavity surrounds the heart within the mediastinum. Let's talk about the features of the pericardial cavity, and then we'll look at an image. The pericardial cavity is located within the mediastinum in the thoracic cavity, and it surrounds the heart. Just like how the pleural cavity contained pleural fluid, the pericardial cavity contains a small amount of fluid called pericardial fluid. And just like how the pleural cavity was lined by a double-layered serous membrane called the pleura, the pericardial cavity is lined by a double-layered serous membrane called the pericardium. Similar to the lungs, there is an inner visceral layer called the visceral pericardium and an outer parietal layer called the parietal pericardium. The potential space between those layers is the pericardial cavity. There is also a fibrous pericardium that surrounds the serous pericardial layers. Let's look at an image to better understand this. If we zoom in on the outside of the heart, we can see the heart is surrounded by the layers of the pericardium. The pericardium can be divided into a double-layered serous membrane represented by the stars and an outer fibrous membrane represented by the circle. The inner layer of the serous pericardium is the visceral pericardium, and it surrounds the heart. This is similar to the visceral pleura that surrounded the lungs. The parietal pericardium is the outer layer of the serous membrane, and it lines the inside of the fibrous pericardium. The potential space between the visceral and parietal layers is the pericardial cavity or space, and it contains a small amount of serous fluid called pericardial fluid that helps lubricate and protect the heart as it beats. The outermost layer of the pericardium is the fibrous pericardium. So we can see how the pericardial cavity in yellow surrounds the heart, and the cavity is lined by the visceral and parietal layers of the pericardium. Let's go back to our flowchart. We now have a good understanding of the thoracic cavity. The thoracic cavity can be subdivided into the right and left pleural cavities, which surround the lungs, and the mediastinum, which contains the heart, trachea, esophagus, great vessels, and thymus gland. Within the mediastinum, there is another cavity called the pericardial cavity, which surrounds the heart and the roots of the great vessels. Now let's move on to the abdominal pelvic cavity. The abdominal pelvic cavity is the inferior portion of the ventral cavity, and it's below the diaphragm, as we can see highlighted in red. As the name suggests, the abdominal pelvic cavity consists of both the abdominal and pelvic cavities. So if we go back to our flowchart, we can divide the abdominal pelvic cavity into the abdominal cavity and pelvic cavity. Let's look at the abdominal cavity first. The abdominal cavity makes up the middle part of the ventral cavity, or the superior part of the abdominal pelvic cavity, as we can see highlighted in red. The abdominal cavity is enclosed mainly by the rib cage, abdominal muscles, and the vertebral column. The diaphragm forms the superior boundary of the abdominal cavity, and an imaginary line at the pelvic inlet forms the boundary between the abdominal and pelvic cavities. Some of the main contents of the abdominal cavity include the liver, stomach, pancreas, spleen, kidneys, and intestines. The abdominal cavity is lined with a serous membrane called the peritoneum. Similar to the pleura and pericardium, the peritoneum has two layers, the inner visceral peritoneum that covers the internal organs or viscera, and the outer parietal peritoneum that lines the wall of the abdominal cavity. The peritoneal cavity is the space between the visceral and parietal peritoneal layers, and it contains fluid called peritoneal fluid. The peritoneal fluid helps lubricate most of the abdominal organs. The terms peritoneal cavity and abdominal cavity are different, so let's take a closer look at these features. Let's look at a side view of the small intestine in the abdominal cavity. The small intestine is attached to the posterior abdominal wall by the mesentery. The peritoneum is a continuous serous membrane that folds on itself to create two layers. The inner layer is called the visceral peritoneum, and it covers most of the internal visceral organs of the abdominal cavity. The outer layer is called the parietal peritoneum, and it lines the walls of the abdominal cavity. There is a potential space between the visceral and parietal layers called the peritoneal cavity or space, and it contains serous fluid called peritoneal fluid that helps lubricate the organs. The peritoneal cavity is exaggerated in this image since the other internal organs are removed. The organs that are completely wrapped by the visceral peritoneum are known as intraperitoneal organs, and they include the liver, stomach, spleen, jejunum, and ileum, to name a few. There are also structures that are in the abdominal cavity, but they are extraperitoneal, meaning they are not covered by visceral peritoneum. For example, abdominal organs can be located behind the peritoneum or peritoneal cavity, as indicated by the star. These structures are called retroperitoneal structures because they are behind the peritoneum and the retroperitoneal space. Remember in our medical prefix video, we said retro means back or behind. If you look at the star, you can see these structures are covered by the parietal peritoneum anteriorly and attached to the posterior abdominal wall posteriorly. Some example organs located in the retroperitoneal space include the kidneys, adrenal glands, and part of the pancreas. Organs can also be below or inferior to the peritoneum or peritoneal cavity, as indicated by the circle. These structures are known as subperitoneal structures because they're below or inferior to the peritoneum. An example is the bladder. So make sure you know the difference between the abdominal cavity and peritoneal cavity. The abdominal cavity is the entire cavity, whereas the peritoneal cavity is the potential space between the visceral and parietal peritoneum. Finally, we have the pelvic cavity. The pelvic cavity is the inferior portion of the ventral cavity. It is enclosed by the pelvis and pelvic floor muscles. The pelvic cavity is continuous with the abdominal cavity superiorly at the pelvic inlet. The pelvic cavity mainly houses the urinary bladder, reproductive organs, pelvic portion of the colon, and rectum. Since the pelvic cavity is continuous with the abdominal cavity, the fluid and membranes will be the same. The pelvic cavity is lined by the peritoneum, which includes both the inner visceral peritoneum and outer parietal peritoneum, just like we saw with the abdominal cavity. The peritoneal cavity is the potential space between the visceral and parietal peritoneum, and it contains a small amount of peritoneal fluid. Remember, some of the structures in the pelvic cavity, such as the bladder, are going to be subperitoneal below the peritoneum as shown by the blue circle. So the pelvic cavity is the entire cavity enclosed by the pelvis, as shown in green, whereas the peritoneal cavity is the potential space between the visceral and parietal peritoneum. If we go back to our flowchart, we can now see we have a good understanding of all the different body cavities by organizing them and breaking them down. Here is a table that summarizes everything we learned to make it easier for you. The flowchart and table can all be found on the website, linked down below in the description. Hopefully this helped you better understand the different body cavities and membranes. If you found the video useful, please show your support and hit that subscribe button. Don't forget to like and comment as well. As always, you can find all of the notes and pictures for this video on the website linked down below in the description. Thanks for watching, and hope you check out future videos.